Let's talk about the equation for today. Newton's second law, F force equals m mass times acceleration A. The units of force are the Newton. The units of mass must be, for all purposes, in kilograms. And the units for acceleration need to be meters per second squared. So what we look at when we are looking to do some problems, we see that in our equation we have the two equations where we had, we should have had, force here, mass here, and we had a line there. When we calculate that slope as change in y over the change in x, we rearrange that to be the y value here being force divided by the x value, mass. Then upon looking at this equation rearranged, we actually find out that the slope is the acceleration of the object. In our particular case, the force was being provided by the force of gravity. So when we talk about A being the force of gravity, which we denote by Fg, then we have to rename acceleration due to gravity as little g. This is different than big G, which is the universal gravitational constant, which we will not be dealing with at all in our discussions. So we can go ahead and take that one off of there. That one will be not dealt with by us. So we take it a step further, and we are going to rewrite our F equals ma equation, and F becomes now Fg. We still have mass m, okay? And now A becomes this g. In some books, as we have looked at in the case of Noah Newton, Fg, which is the force of gravity on an object, can also be determined as weight equals m times g. So all three of these equations, F equals ma, Fg equals mg, and W equals mg, are all the same equations, just depending on do you know, is it something that's being pulled in the downward direction, then we need to call it Fg or W for weight. Coming back to here, the acceleration for units that we have had up until now, let me just say units, have been meters per second squared. However, we know now that, according to this equation, it could be newtons per kilogram. So, or newtons per kilogram. They are both the same unit, and we do not need to choose one over another. They are one and the same. So it is just a matter of whichever one you choose to use. Now, generally speaking, when we're using this equation, regular acceleration, we want to use meters per second squared. But when we're using g down here, we definitely could be either newtons per kilogram or W equals mg. So let's look at some possible calculations and examples to this. Let's see. That's not going to do that. You also told me you like that color, so we will go with that. Problem. consider the book at rest on a surface. That is my book here. If I wanted to draw the force diagram, let's say the book had a mass of 2 kilograms, and they want us to know, they're asking us what is the force of gravity on that book. Well, we know when we draw the force diagram of our book, which is the system, that my downward force is the force of gravity on the book by the earth. And then I have an equal upward gravity, so we're going to call the force normal on the book by the surface. These two are equal. The force normal is equal to the force, I'm lying to you. Let's fix that. We'll erase this and we will change it to the addition of those two forces have to be equal to 0. The sum of those forces in this direction must be 0. So because we're dealing with Fg here, we know that we can take this equation and rearrange it to Fg equals m times g, because we know what that value is. We know that little g acceleration of gravity is actually 9.8 meters per second squared, or newtons per kilogram. We'll round it. We'll round it because the name of the class is conceptual physics, so we are okay to just do, make the math easy. So all I'm going to do is I'm looking for Fg, and I know my mass is 2 kilograms, and I'm going to multiply that by my g, which is 10 meters per second, squared, and my Fg is 20 newtons. So this is how we solve those equations in equilibrium. So this is how we can determine. So now I know I have Fn, my net force equation, plus Fg equal to 0. Now, this Fg is in a negative direction because it's going down. So I'm simply going to put that in there, and I'm trying to calculate Fn, so to get this to this side, I add by 20 newtons. So F, the normal force on the object, is 20 newtons. So this is how I can say that I can calculate this force if I know the mass of the object. So I hope that helps.